बिस्मिल्लाहिर्रहमानिर्रहीम अल्लाहुम्मा सल्ली अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलिहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा अल्लाहुम्मा रब्बना आतिना फ़िद दुनिया हसनतन व फ़िल आखिरति हसनतन व क़िना अज़ाबन्नार आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन अल्लाहुम्मा सल्ली अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलिहि वसल्लम. In this lecture, I will solve question 6 of June 21, paper 42. This question is of momentum. A particle A is projected vertically upwards from level ground with an initial speed of 30 meter per second. This is the velocity of projection of particle A. At the same instant, a particle B is released from rest. Rest means its initial speed is 0. 15 meter vertically above A. This is the height of B from ground. The mass of one of the particles is twice the mass of the other particle. This means two possible situations. Maybe mass of A is twice of mass of B, or mass of B is twice of mass of A. During the subsequent motion, A and B collide. This is the momentum, and coalesce to form particle C. So let me explain this situation through this sketch. This is particle A, and its velocity of projection is 30 meter per second. Here is particle B. It is at rest, so its velocity is 0 meter per second. And this height is 15 meters. Well, when both particles collide, a new particle will form, which is particle C. This is particle C. This is A and this is B. We would need this time when both particles meet or collide. This height as well. Height of A from ground. This is height of B. We would also need velocities of both the particles, VA and VB, at the point of collision. So this is the situation. You can say this is the given information. Well, this is also given. Mass of A is twice of mass of B. I'm sorry. And this is case 1. Case 2, mass of A, mass of B in fact is twice of mass of A. Now we have to suppose mass of B as M. Therefore, mass of A with respect to this equation is 2m. Here we have to suppose mass of A as m. Therefore, mass of B according to this equation will be 2m. The question is, find the difference between the two possible times at which C hits the ground. We would have two different times because of these two different masses. And we would need time of this and time of this. This is T1 and this is T2. Then we would need difference between these two times. This is the question. So this is the given information. This entire thing is given. Now first I will find this time. Then I will find height of A. And then I will work for velocities of A and B at the point of collision. And then I will find two different times. Now I'm going to find time when both particles meet. For T. As we all know, height of A plus height of B is 15. This plus this is equal to 15. And we know this equation, S is equal to ut plus half gt square. For A, g is minus 10 because A is moving vertically upwards. For B, g is plus 10 because it is moving vertically downwards. So according to this equation, height of A will be ut. The initial speed of A is 30. Time is t. G is negative 10. So minus 5t square. When you will put minus 10 here, you'll get minus 5t square. This is, initial speed of B is 0. So this is 5t square. When we will solve this equation, we will get the time of collision. It's 0.5 seconds. Now we need the height of A. For HA. For HA, I will use this equation. So height of A is 30.5 minus 5.5 square. This is 13.75 meters. So this time is 0.5 and this height is 13.75. Now I need velocities of both the particles. For for VA, we will use this equation, VA U minus GT. U is 30, G is 10, and T is 0.5. So this is 25 meter per second. Since A is moving vertically upwards, so its velocity is 25. For VB, we will use the same equation. VB is U plus 10T. U is 0, 10 into 0.5, which is 5. Since B is moving in this direction, vertically downward, so its velocity must be -5. Now we will use law of conservation of momentum to find the velocity of the particle C. Velocity of C, which is V. So case 1. Case 1 is mass of A is 2m and mass of B is m. Case 2. Here mass of A is m and mass of B is 2m. So according to law of conservation of momentum, total momentum before the collision is equal to total momentum after the collision. So momentum of A and B is equal to momentum of C. Since mass of A is 2m for case 1 and its velocity is 25, this is here. Mass of B is m and its velocity is -5. C is the combination of these two particles. So mass of A plus mass of B. So this should be 2m plus m and its velocity is v. When we will solve this, we will get 15 meter per second. Now the second possible value of velocity of C is A plus B is equal to C. So mass of A is m and its velocity is 25. Mass of B is 2m. Its velocity is -5. This is 3m v. So v is 5. But since particle C is moving vertically downwards, so its velocity will be -15 because it is moving in this direction. -5. Now we will use these two values of velocities of particle C to find two different values of T. For T1 and for T2. This is the height of C from the ground, HA. We have two different values of V, so we will find two different values of T. So for T1, I'm basically using this formula. Height of A is 13.75. So initial velocity of particle C when its height is 13.75 from ground, in this case is -15. So -15 T1, since it is moving downward, so 5t square, g is +10 and 13.75. When we will solve this, we'll get T1 3.736. This is the first possible value of T. for particle C. Here minus 5t plus 5t square 13.75. When we will solve this, we'll get t is equal to 2.232. This is t2. Now we need difference between these two times. Hence, difference between these two times is t, which is t1 minus t2, 3.736 minus 2.232. This is 1.50 seconds. And this was the requirement. You can check the solution again. This is the given situation. I explained this thing in detail. First I found this time, then I found this height, then I found velocities of both the particles, and then I found v, velocity of C, by using law of conservation of momentum. And then I found two different values of t, and this was the requirement, difference between two times. You can find the link of the math website Math by Sir Qadri in the description, where you can find the soft copy of this lecture. Good luck to everyone. Allah Hafiz.